An r-permutation of n different objects is an ordered arrangement of r distinct objects that are chosen from the n objects. So effectively, r is smaller than or equal to n. So remember that n factorial is the number of permutations of n objects, and that was n by n minus 1 by n minus 2 and so on down to 1 by the multiplication rule. But suppose we have r objects chosen from n objects. So therefore the number of permutations of the r distinct objects where r is equal to 1 is n, and where r is equal to 2, the number of permutations of two distinct objects is n by n minus 1, and for r equals 3 we have n by n minus 1 by n minus 2 and so on. So we can see that the number of permutations for r objects in general that are chosen from n and denoted as Pn, r is equal to n by n minus 1 by n minus 2 and so on down to n minus r plus 1. So think about these three cases to be clear. So note that in general n factorial can be written as follows. So we have down to n minus r plus 1, and then the next term would be n minus r, and n minus r minus 1, and so on. So therefore the number of permutations of r distinct objects chosen from n is n factorial, and we want to get rid of the terms after n minus r plus 1. So we divide by n minus r factorial, which is these terms over here. So for example, if we have three different objects in a set, so suppose we have 1, 2, and 3, and we want the number of permutations of two distinct objects chosen from this set. So that would be 1, 2, 1, 3, 2, 1, 2, 3, and 3, 1, 3, 2. So therefore we expect 6 r permutations, where r is two distinct objects chosen from these three objects. So therefore P, where n is 3 and r is 2, is equal to 3 factorial over 3 minus 2 factorial, which gives 3 factorial on 1 factorial, which is 6 ordered arrangements. So as we can see, with r permutations, order matters. So effectively this ordered pair, 1, 2, is different to 2, 1 for example.